Good morning, everyone. So today we will discuss the remaining part of our tutorial problems that we discussed on Monday. So we discussed that time, I think, one example and other two problems. Do you have any question, comments, or anything difficulties you don't understand that one we discussed other day? Anything difficulties? How about this side? Did you do the practice? You have done the practice? So it is easy. As I said, need to read the problem first. As equation is easy, but how it comes and how to get it. Anyway, a little bit refreshing, and then on problem we will discuss. As I said, you are also busy for your this one. Okay, so this is the previous example on. We are not going to discuss further given details, and this one as is discussed, but little bit quick discussion, and then we go to the new problem. Because if you have little bit issue, refreshing and then run the new one. So this one, as said, three-phase round rotor synchronous generator, negligible armature resistance. What does it mean? I have a question for you. Your friend told last time. Negligible armature resistance.
R equals 0.
Huh?
R equals 0.
R is equal to 0. Okay, backside. That is the assumption, approximation, condition. If you forget that one, then at the end you cannot solve. So that one is good so far. You understand? Very good. Thank you. Okay? And then say reactance, XD, skip. Then connected direct to infinite bus of voltage. And then that is 1 per unit with angle is 0. And then say you have to calculate your internal voltage with different conditions. I'm not reading that on with your when machine delivers the current 1 per unit with 30 degrees. What does it mean 30 and it minus 30? Because there is 30 degrees, 0 degrees, then minus 30 degrees. Leading or lagging, which one is what? Plus and minus, how it? Leading,
Leading is
and then lagging. Okay, and you have to draw the phasor diagram. Look, I explained, but that's fine. I'm a little bit repeating. Even some feel, oh, if I ask them, it will be difficult. Actually, not. So, but example was only one condition. Then we pick that example and then three conditions. Does it make sense, Jared? Then I think nobody will not forget if you little bit careful and listen. Right? So understand? Leading and lagging. Already in your book, but explanation.
Yes.
Huh? Sorry? Anything unknown?
No, it's true.
No,
Yeah.
we did that on lagging first in your example, and then the similar problem, that's why I picked up that one, and then that's why I selected this, and then different one. Okay, so far try to proceed, and otherwise I will finish my time. Better to discuss how it's going on. All right, so far you are calculating your EI, right? What does it mean, EI? EI, like this equation, already in your, sorry, what is VA? Last time we said, as voltage, I think. If you go back to the problem, yes, already given infinite bus per unit. And then you have your current, and then given your XD. And then you said armature resistance is, what is the value of armature resistance? 0. That's negligible. All right. Still, someone will be finished. You say that's the answer. So far, you can calculate internal voltage EI is equal to VA plus your J of XD and I. What does it mean that XD and I? This one drop due to the inductive component. All right, and then you have given this value, this, and can you calculate or cannot? I'm not going for the calculation. Is it difficult? So you understand? So this side you understand? If this type of things, hopefully you can solve. Design problem. Engineer will solve the problem. Problem solver. So far, that's fine. From this equation, I think you will get it. And then E, you have your V, this on, and then XD, this is your 30-degree angle is here. All right. So far, see the resultant. This level. Any difficulties for this one? Or you think this is not right? And then similarly, we will use that voltage and current. I think next on that angle is 0. So I have a question for you here. Do you understand why that dotted line, what it means, 30 degrees, and other one is not? You can see where is your eye. Physical representation. You understand, Jared? I hope you understand. You are mostly attending. A 30-degree eye around there, but for B question I, that angle is 0 degree. So align with V. That's why. I did not explain this last time, but today I little bit, when I read myself. Do you understand what I said today?
Yes.
First on, you have voltage and current. There is angle.
Yes.
How much? 30 degrees. Very good. And the second one? 0. What does it mean? Voltage and current?
Same direction.
Same direction. Align. Does it make sense? This is not written, but I hope you understand now. And then I will show you when it is negative is coming. So because last time I discussed a bit quick, rush, right? Today is clear more. What do you think, Jared? Align, that means 0. Does it make sense?
Yep.
You can sleep and then remember if you have the concept. Yeah, even if you go home, say this is the angle, but this angle becomes 30 degree, then it's 0, voltage and current is 0. That's okay, it's 0 condition. Does it make sense?
Yep.
Plus 0 and minus. I asked you this question at the beginning.
Yep.
Is it interesting or not interesting? You know 3 conditions, but your example was only 1. That's why I picked up this one. Or it is hard. I'm pushing you too much. So giving you this conditional, you will get this sort of problem in your reality when you go for job. All right. I think it is clear to everyone. And the C part you can understand easily. So, as I said, so this 30 degree, does it make sense now? And then here, voltage and current aligning, so there is no angle because this one 0 degrees. All right, and then so you can draw the phasor or cannot. Voltage, current, and the XD, and then you can see relationship. So voltage and current, XD always 90 degrees, right? You see here, and then you're getting the resultant EI here for this one. Is it difficult? Okay. Now, if my angle is minus, what will happen? I need this answer from all of you. So, current line will go dropping down, hopefully like this direction. That means something like here and around here, but I'm not drawing here. I will show you in another way. Okay? So far, can I go for the next? Up to this, do you need calculation? I think calculation you can do. Operate your calculator, you will get it. Very simple calculation. Can I proceed? Okay. As I said, voltage and current relationship for this one is how many degrees here? This one is minus 30 degrees because this is your voltage is 0 and then current here minus 30 degrees, that is given. Yes. And then your XD is coming and then E resultant EI. So this one is same as before, V plus J of XD I. Is it difficult to draw the phasor for this one? You know about three conditions. Angle. But if voltage has some angle, current has some on that angle, you can shift it. Otherwise, you say, I will do 20 problems. No. Usually on, and then I personally realize at least to show you what is leading, lagging, and in phase. That's the same angle. Does it make sense? How about this side? Then we'll go a little bit different one. Okay, so you can understand this. And then, as I said, during break is fine, but I would request everyone do something recap. Even I do for my teaching, other thing, other task. This is my advice. Of course, you need to relax, refresh, that's fine. A little bit recap is better. What do you think? Otherwise, no need to touch anything. But whenever you are free and able. Anyway, so far, does this phasor diagram make sense? All right, so far I believe it's okay now. EI, so you can get, and resultant angle of this one is 38 degree. So where do you can see this angle? Can you see? 38 degrees. This one is 90, so around here, 30, halfway through. That one is more smaller. When your voltage is angle is 0, current with minus here, and I think around, it should be around here, plus on. Okay? Can I proceed or need further explanation? So I think everything is clear, so hopefully you can understand. Can I proceed? Because that magnitude and polar form always with your, like this is and this is angle. If like this and this is base and this is minus side. I think you learn in college or school. I learned long way back, maybe. But whatever the teacher said, we have to acknowledge that we need that on to use for today's engineering studies. Polar form. Anyway, so hopefully it's not a problem. Now, I have one problem pending. I want to do that. Do you have any questions? Today we discussed that on a little bit rush last week, but I think it's not clear, and then we want to discuss this problem. What does this problem say? When you are engineer in industry, you do big problems, like a sample problem. They say usually you will get FLD when you write sometimes, but here single line diagram. Okay, as shown in this figure, that's fine. And that is, say, generator and transformers are connected, and the configuration is as follows. I'm not reading that one, but then G1, G2, G3, different types of generation from different places, and then there is transformer. What usually happening when generation, and then what they are doing? Power generation is a bit far away than city. What they used to do? Generate and then transmit where consumers and industry are there, and they want to use it. Customer, right? So you are engineer, power station or whatever, you need customers. This one is not written in your text, but very general and basic understanding, but we have to explain how make you that level, and then so far they need, you cannot generate high voltage. I think maximum generation 11 kV so far, but we have to step up. How we are doing a step up and a step down? Usually, sorry?
Transformers.
Yeah, transformer, step up and step down. So when generating and then a step up and then high voltage, then low current, transmitting, then this is a transmission line, right? And then coming and then again, voltage dropping down, step down, transformer, and then going for domestic, household, whatever the use. Okay, is it difficult to understand? That one is because I want to explain this related to this problem. So they say, and then sending to the transmission side, not discussing further. So you need your transformer and transmission line. Okay, so and then they say the generator on, this one is rated as 20 MVA, this one, generator 2, generator 3. And then transformer rating is different. 25, 10, and 35. But there is given condition, you have to use your base. So you have to follow that reference. That is selected. And then solve the problem. Okay? And then, as I said, say 3 questions. As I said, try to understand the problem and then we will go for the solution. First one, say you have to draw the impedance diagram with all reactances marked in per unit with letters to indicate points corresponding to the single line diagram. Letters means that you can see the A, B, C, D, and T. So do you understand that? Okay. So far, if we think and little things you have to understand. What is the connection? This is what sort of connection for this one? First one. Y connected with neutral is there. You can see transformer is delta Y. Someone think, oh, little symbol doesn't matter, but that is important, especially for your assignment also. Any problem solving, and it will change your results. Okay. So far, first on here, say generators G on, we consider it here. Then say 50 MVA base and on 13.8 kVA the voltage rating, but generator is given 20 MVA, 13.8 kVA, and XD is 0.20 per unit. That's fine. So if you change to the selected base, what it will happen, and how to do that one? Because say 50 voltage rating is not affecting, so you have your transfer old base to new base. Okay, that's fine. But if I think for this one, 0.2, then already 20 MVA, but say 50 MVA. This 13.8, 13.8 is okay, it will not affect, but then it will change with 50 by 25 to per unit. This one is easy, right? And can we do for generator number 2? You can do. Answer is there, but how to do? Just I want to know your technique. Okay. Say 0.2, but rating is 30 MVA, but new base is 50. Very similar fashion you can do. Should be 0.20 times your new one divided by old one. So transferring to new. 50 divided by 30. So 1.67 times of that one. So it would be 0.33 something. Yeah, that's right. Can you calculate? Similarly, everything you can calculate for the generators. You can? Do you understand what I said? Is it difficult? It's possible to do. Okay, because we did something this on before, the per unit on, and then how to change the old base to new base. That means new rating is 50, old one is 30, so it will be increased. But if it changes 50 to 30, then it will be decreased in smaller amount. So that is the concept. So I'm not doing the calculations, I'm explaining how it happens. Okay. Anything difficult to understand? Then you understand for generator 3. Understand? Okay, and that one say also 30, and then yeah, it's mostly 30 MVA. Okay, so this on 30, 18.20.33. That kVA is changed also for generator 2 and 3. So for yes, so just consider that one, and you will get the rating. And then coming to the transformer, first I will say 10%. What does it means? 10% actually 0.10, 10%, and then 25, so MVA, so 0.2, and then transformer 2, you are getting also, no, transformer 2, 10 MVA, 10%, and 1.6 single phase. Okay. This one is say single phase 5 times. What does it mean? Say single phase is rated 10 MVA. If 3 phase, then what will happen? You can say there is 10 MVA for each rated. If 3 phase, it will be 3 times. Then 30 the same, and that's why getting 0.167. How it comes? Yes, sometimes I also forget. So for that's why getting this value is 3 times 10 MVA we are using, and then this is 10%. So far, base is 50, 0.10 times 50 by 30. And hopefully this one will be simple calculation, but how to do that one, that is the technique is important. Do you think calculation is difficult? No, calculation is not. That's why suddenly as I ask, single phase rated 10, if you consider a 3 phase for the whole system. Is it okay for you? How about this side? Understand? Or it is difficult? Okay, you got the message? And then you got 35 MVA because this one did not mention anything but 10%, and then how to transfer that on 35 and 50. The same. So this one will get it 0.10 times 50 by 35. All right? Is it okay? Something written there, but how it is that I want to put it, the answer. Now, another one, your transmission line. So this one is given your line like impedance. You have to calculate the jet base and then get that on. Finally, you will reach this sort of things. So how this one, as we calculated before, so this one, if I see, it was, this one was 0.2, actually 0.2 times 50 by yes, getting. Similarly, all you will get, including your like other side. This one is okay. Just hold on. This one is T1, T2. T2 is, this is actually 1, 2, 3. So far, okay. This one was difficult because this one 0.10 times 50 divided by 3 times 10. Side. Is it difficult? So you can solve in other things. So as I said, do some practice. Any difficulties, sometimes you may don't get a little bit different value, that's fine, but as I said, procedural technique and operate that on. Then you can reach there. But if you don't task with your pen and pencil and note, everything in computer, that's fine, but better to do the practice. Yes, in computer I agree, fully agree. When you go to the field, you have to measure and then put on the paper. And then calculation is difficult. Then as Tony said and myself also, calculation is difficult. So use MATLAB and program, that's fine. That will give you the save the calculation time, but concept and knowledge is important. What do you think? Yes, so you understand? So can you do the practice and then it will help you to solve the problem. Is it difficult? There is difficulties, but need to do the practice on. Otherwise, if I solve all line by line, he did, I have seen. Not that one. So you will do difficulties, ask me, we'll solve together. Refresh your mind and make more reliable and confident person to solve the problem. So perfect engineer. Does it make sense or I am saying something wrong?
Makes sense. Good.
Okay, so you can calculate. Look good, she's doing, that's very good. That's why I said do some practice. And then you get the understanding well. All right. So far, and then hope you can calculate all of these, all the components, and that's why do your practice. And then how to calculate your short circuit current, because this one is calculating your this is like first component. This is your 0.7, yeah, coming from this part. Okay, and then this one is 0.1. This is 3, 4. This one is, I think, this part, and then this component. You get it? As any difficulties? How to get that summation that I want to show you? Does it make sense? Because 1 over 0.5 plus 0.2 plus 0.83. So 0.783. So now you know how it comes. Do you want I have to calculate line by line? I will give you the hints how it comes. So you understand? So you can, the simple math. So all, because that point, as C, you can see all wires are connected over there. How the configuration it looks like in a junction point, like that. And then we're getting this, and finally to this on, yes, we have to calculate your base current. That on already given the condition S base, that is chosen base for the configuration. All right, and we can proceed for the next. Then calculating is generators. Supplied by generator, how much? Supplied by generator 2 and generator 3. That means supplying by individual generation plant coming to the transmission line. So they are calculating how much power generating and transmitting. Does it make sense? Because it's all calculated and then automatic system and should be balanced without any issue. So as I said, do some practice and then make more confident. If not, discuss with me, also with Tony, discuss with the forum. And as I said, this one will help you to solve your assignments, even final exam questions. Final exam, I think in June sometimes. Should be in June.
We don't know the date yet.
No, that they will announce, because exam is not with us, this is examination section, when they said, but it will post to the study desk definitely. They will post it. Okay. So, and then finally, fault MBA, say root 3, line voltage with system unloaded, and then line current during fault. So fault MBA, if it happens any fault, then you have to calculate with the fault current, fault MBA, that's what I said. And then line voltage with system unloaded. What was the situation over there? Okay. So far, so you can calculate, or do you have anything specific question or any difficulties? Do some practice. And then about your assignment, as I said, follow the guidelines. Do the same thing first. Then you can get knowledge, technique, confidence, and then touch the new one. New one, as we said, little bit different than previous, but if you understand the sample, then you can do. Like example, what I did, example. If example is clear to you, then you can clear the problem, real problem. Or do you want always example? You don't get always example, but example will give you the confidence. Makes sense. All right. Any other question or comments about this side? Do you have anything difficulties? So far, said no. Do you have? No. Do you have any comments or question? So try to solve. I understand you are not asking right now. Anything problem, then send question to forum. And then we have next 2 weeks, hopefully the break. And break time also we will respond, but not so frequent. Okay, there is another additional problem in your, no, that one was exercise and additional in given in your study book, little bit short that one. Answer is there, but I think explanation not 100%, but it will help you to solve the problem. Okay? But if you say, I solved this, getting different, he solves this, and then discuss, interaction. I can do mistake, you can do mistake, but then discuss and then get the right answer. Okay. This one say infinite bus, and then generator EMF, reactance and active power, and then reactive power P and Q. Do you know P and Q relationship? Already in, that is like S so far, and then this one explained with the triangle, right? Active power and reactive power, and then you get the S. Okay, see? Okay, showing this one, said this one will help you. I recommend follow this one with the help of your textbook. Important. Then they said EV by X, and then maximum allowable active power. And then this one explaining with this, you can see, where is your P? This one is your P. This is your Q, I think. Just follow this one. It said permissible region of operation, where you can operate. You can say safe operating region. Yeah, that's all. So I would say a little bit do the practice. Just showing you This one is prescribed and given to you for your understanding, of course. If you don't do the practice, then, but feel free to ask the question. That's fine, no problem. But if you don't ask, then I thought you know everything. If you ask, then good for you. Need practice, right? You want to go for longer, or you want to, we can stop here. And if you have question, feel free to ask. Do you have anything difficulties? No? How about this side? Okay, mostly understand. If no question, we can finish it here. But I hope for everyone on campus as well as external student, do your practice and then ask question. Also, wish all the best during your this happy Easter break. Okay, but you can send message. We'll try to respond as quick possible, but maybe a little bit delay because break time. All right, and then I think your assignment is coming soon. When it is 18 or something.
Yeah, I didn't know. It's the second Monday back.
Yeah, I think so. Okay. So, but you can ask some questions, but follow the guidelines. Hopefully, it should be okay. Okay. All right. So we can stop here. Thank you very much for your participation, attendance. I wish all the best during the break time, Easter break. All right.